welcome to another welding spacecast. All right, guys, today we're going to talk about shield metal arc welding, the type of equipment. We're going to talk about some electricity and all of that. Okay, so here we go. All right, onwards. Well, if onwards would work. All right, here we go. All right, so the first thing we're going to talk about is alternating current. The way a current is, or let's be more specific, electricity. It has a positive and a negative cycle. It's kind of a wave, so it goes up and down. This line right here represents 0. So it's kind of like math. So when we have 0, this would be positive and this would be negative. So what happens is alternating current has both. A half of it is positive and it droops down, it goes to 0, and then it goes to negative. Okay. Alternating current isn't usually used in stick welding for structural material, but it can be used. Okay. And it makes the current go back and forth to our workpiece. So there are certain things that require it. So we always have to remember that not everything requires it, but sometimes it does. All right. The other thing is, the first one is direct current electrode negative. So what do they mean by electrode negative? So when we're talking about the electrode, we're actually talking about the rod itself. That's another term for rod, electrode. Okay? And they're saying that it is negative. And the other thing is positive. That would be our ground. Our ground would be positive. So that means it's the way the current flows through. So if it is electrode negative, okay, it flows from the electrode, from here, into my work and down, okay. So electrode negative is a bit of a new term. So they used to call it direct current straight polarity, or DCS as in Sam, P. And it tells me it is straight. So if it is straight, I know it goes straight down. Okay. Now, there's another one. Direct current, well, they don't have it. Direct current electrode positive. Okay. Well, here it is. Electrode positive, it means my electrode itself is positive and my ground is negative, which means if I work in electrode positive, it goes from my work up into the electrode and around. Okay. So there's two different ways, and this is the other term for electrode positive would be DC reverse polarity, DCRP. So we know it reverses, it goes into the other way, it reverses up. All right, so the next thing we're going to look at is voltage and current. You guys have noticed that there's a little thing that says V and another say that says A. All right, A is for amps. Another word for amps would be current. Amps and current affect your heat. So I may ask you, what is your heat at? What are you set at? Okay, well, we're going to talk about amps when we say that. All right, open circuit voltage. So I've got my machine on. I have my ground plugged in. I have my electrode and my electrode holder, my stinger. We're ready to go. We're ready to weld, but we haven't touched it to the plate yet. The lights are on, but nobody's home. Okay, so as soon as we touch it, it becomes arc voltage. Okay. All right, so we really need to understand positive and negative because it creates polarity. Certain rods require certain polarities to work correctly. Certain types of material require certain type of polarity for it to be welded correctly and to melt. Okay, so we need to understand that. So whether we have an electrode positive or an electrode negative, it tells us just what way the current is flowing. All right, now we can talk about different types of machines, okay? And machines have different types of output. AC, or alternating current, direct current. Direct current means it can only flow in one direction. So maybe I'm talking about DC electrode positive. it can only go one direction, the positive direction. If I talk about DC electrode negative, it can only go the reverse, or excuse me, the straight way, okay? It's only going in one direction. It cannot go both, okay? So we have AC and DC, okay? And different machines, depending on what we're trying to do, can have both or can just have one. Okay, an AC/DC machine is commonly used for stick welding. There's also a particular power source that's required in these machines for them to melt the material correctly. One is called constant current, CC. So constant current tells us that the machine will always try to keep my current or my amperage the same. Okay. Now, if I can have a different type of machine, a constant voltage machine means it is trying to keep the volts the same. Okay. So an SMAW machine or a stick machine requires CC or constant current in order for it to work. Okay. All right, so here's our constant current machine, and this is how it works. Okay, so here's our voltage. So ultimately what the machine is trying to do is change the voltage in order to keep the current. So maybe I set it at 100 amps. And I want to keep that 100 amps no matter what I'm doing when I'm welding. So it will change the voltage in order to accommodate what I'm asking, keeping the amperage the same. But when we have a long arc or a short arc or a regular arc, it affects our heat. Okay? So we want to make sure that we are consistent. Okay? That little fire that comes out, okay, from the end of your electrode to your plate, okay, that is called arc length. We want an arc length about the size or about the diameter of our electrode or our rod. So currently we are running 1/8 inch E6010. So we want the arc length to be 1/8 of an inch. Now, so that would be our normal arc. But if I got shorter than that, it can change my current. And if I got longer than that, it can change my current. So if I go too long, it'll get hotter. And if I get too close, it'll get cold and more than likely it'll stick. Okay, so depending on what I needed to do, depends on what terminal I plug it in, to the positive or to the negative. Let me tell you about the machines. There's all kinds of machines, okay? There's not just one machine that does it all, okay? There's not one rod that does it all. There's not one process that does it all. And there's not one machine that does it all. So you need to make sure that you understand that we need to choose the machine that's right for the task. Okay, so this type of machine is called a transformer rectifier. Usually does DC current only, whether it's DC electrode negative or electrode positive, it only does DC. Okay, these are big old behemoth machines. These are probably looking at about 500 pounds, 500 pounds. That's why they have that little hook on top, and it makes it a little bit easier for them to either put it in a crane or put it on a forklift. Okay, these usually machines have a lot smoother arc. The arc is very consistent. And this is probably the most common stick machine that you're going to see in big shops. Okay. The other one, inverters. Inverters are the coolest machines, and that's probably some of the newest technology that's out. Inverters allow us to change the frequency of our wave, whether it's higher or lower. But being able to do that also allows us to make a smaller machine. The components can be smaller. Okay, I'll come back here. Okay, so because our components can be smaller, that means we can do a lot more different things with it. So like if you notice, there's a lot of machines that are stick machines that are, the size of a shoebox. They're getting smaller and smaller. Okay, and the other one is engine-driven. Okay, these machines are great, but you also have to remember that these are meant for outdoor applications. There is exhaust. Okay. Most of the time, they only do DC. If you want one that does AC, it's considerable amount of money. And I've noticed personally welding on an engine-driven machine, whenever the engine idles or whether the engine comes on or off, it will also affect your arc. Okay. All right, so here it is. So we can get ones with alternators or rectifiers, alternators and inverters, or DC generators. Okay, and then it also says it has AC only, AC and DC. Some are CC and CV. We know CC is constant current. CV is constant voltage. CV is necessary for any type of wire feed, like MIG or flux. Okay. Oh, well, this one has a DC, so we have to pick and choose what's necessary for our engine-driven machines. You can get an engine-driven machine, probably looking between $1,000 and $80,000. So there's all sorts of different things that you can get on it, but it also depends on your need. All right, duty cycle. Duty cycle is really important and you need to understand. What duty cycle is, it is a percentage of time that I can be welding at its rated capacity. And there's a number associated with it, okay? So this says, for example, when welding with a stick machine and 20% duty cycle, okay, 20%. Well, it's usually on a 10-minute period. So if I say 10 divided by 20, it would be 2 minutes. I can run this machine for 2 minutes. But that also means that in that 10-minute cycle, I have to let it wait. I need to let it wait for 8 minutes to cool off. Okay, so it's really important that we understand how this works. So if you guys have questions, please come to me. So let's give another example. On average, many duty cycles are 60%. Okay, in a 10-minute period, that would be what? Okay, that would be 6 minutes. Now, how many minutes need to be resting out of that 10 minutes? Well, 10 minus 6 would be 4. So I need to have 4 minutes resting. Now, what happens if I run my machine past that? Well, you're more likely to melt down the component parts of your machine. First thing you're going to do, you're probably going to hit a reset, and the machine's going to go until it cools off. And I've actually seen it when somebody hits it too much, it actually melts the machine down and you can no longer use it. It becomes bad. All right, guys, I will continue this in a part 2. Take care.